Hello everybody, we're going to talk about an idea called integration by parts. And to begin this rule, let's recall that in derivative calculus, we had a rule for finding the derivative of a product of two functions, u times v. Now, let u be a function of x, it's differentiable, and v be a differentiable function of x as well. Well, the derivative of that product of u times v is equal to the derivative of the first function u times the second function v plus the derivative of the second function v times the function u. All right, when we proceeded with other rules in calculus before to give our integral rule, we used a differential notation that went kind of like this. If we wanted to take the derivative of u times v, it would be u prime v dx plus v prime u dx. That seems a little bit awkward, that's notation. Let's clean this up a little bit. So let's rename a couple of things. First of all, I'm going to let du equal u prime dx, right? So that's going to be our replacement there. And dv be v prime dx, right? So that would be this would be our derivative notation for each of the u prime and v prime separately. So now our rule looks like this. The derivative of u times v is v times du plus u times dv. Now, it was from this kind of rule that we developed our integral. That is, we would integrate both sides and we would get an integral rule. So here's what it looks like here. Again, this seems a little awkward, but the way that we actually use this rule is that we isolate one of these integrals, and that's going to help us find the derivative, or integral, pardon me, of, I'm getting mixed up, our integral of u times dv, let's say, by subtracting one of the other integrals, so integral of v times du. And there's a method for using this rule called integration by parts, and that's the rule we're going to learn today. So let's consider one function that we can use with this. Here it is. We've got this product, the integral of x times e to the x dx. It would seem like a simple function, but so far we have not developed any rule that would allow us to handle something like this. So what we have to do is play this game. We have to require one part of the function to play u and another part of the function to play dv. So the question is, which one do we want? Well, we have a couple of choices right here, right? We say that, well, we could pick either one. The one we want to pick is dv first, since the goal of this method is to simplify this expression and not make it a more complex function. So how do we do that? Well, let's consider what we could do. One way of handling this would be to say, all right, let's say we pick dv to be x times dx. That means that we would be picking u to equal e to the x. Let's see what happens if we rewrite this. If dv is equal to x dx, we want to get v, and that means that we would have to take the antiderivative of x dx. By the way, we don't add a constant of integration at the end of this when we use this rule as an antiderivative. We don't do that until the very end. But if we were to take this antiderivative right here, we would get 1/2 x squared, right, plus a constant, but we're going to leave it as 1/2 x squared. That constant will be, and of course we would take the derivative of u, which in this case is mighty simple, right? It's e to the x dx. This doesn't really do it for me. You know why? Because if I were to apply this rule right now, look at what we're going to get. The integral then of x times e to the x dx is going to look like u times v. So we're going to take v as 1/2 x squared e to the x. We're going to get 1/2 x squared times e to the x minus the integral of 1/2 x squared e to the x dx. Remember what we said about not making it more complex right here? That's kind of complex. I hate it. We're not going to go that route. Let's rewrite this guy. What if we said then that u, uh, instead of being e to the x, was x, and dv was e to the x dx? How does that help us? Well, first of all, if we take the derivative of u right away, something goes away. We don't add something, right? We get just dx, 1 times dx. And, of course, integrating on both sides to get v, we get v equals e to the x. That's a really nice thing for us. So now if we rewrite it, our integral x times e to the x dx is going to be equal to u times v. So we're going to take x times e to the x, but we're going to subtract from that the derivative of v times du, right? V is e to the x times du, which is dx. Now that's a much simpler integral, right? Because that becomes x times e to the x minus the antiderivative of e to the x, which is just itself, e to the x, plus a constant. And this is much simpler, right? We get rid of the integral right away instead of complicating matters with squares and other things like that. And that's a lot of the trick in using this rule. How do we actually find which one we want to give as x and which one we want to give as dv when we start?